Hello, everybody, and welcome. My name's Griffin, and in today's little mini lesson, we're going to be talking about the unit circle and how it relates to trigonometry. So let's draw our circle. Here we go. So what exactly is the unit circle? Well, the unit circle is a circle such that the radius is equal to 1. The radius of our circle is equal to 1. That is the unit circle. Now, what is the equation for our unit circle? Well, think of Pythagorean's theorem. Pythagorean's theorem tells us that if we have a right triangle, then we know that the legs are A and B and the hypotenuse is C. Then we know that a squared plus b squared is equal to c squared. Let's carry this thought over to our unit circle, where this coordinate point here is some distance x and some height y. And we know here, let's change this to a right triangle or draw out our right triangle. Here in red, we have a right triangle with some base length x and some height y. So we know that x squared plus y squared is going to be equal to our hypotenuse squared. Our hypotenuse is 1, and 1 squared is simply just 1. Therefore, the equation for our unit circle is x squared plus y squared equals 1. Okay, so that is what the unit circle is. Now, how does this relate to trigonometry? Well, one of the first things you learn in trigonometry is the word or the expression SOHCAHTOA. And what does SOHCAHTOA mean? What does it tell us? Well, SOHCAHTOA is a little mnemonic that helps us remember that the sine of some angle theta is equal to the opposite over the hypotenuse. And it tells us that the cosine of some angle theta is equal to the adjacent side of the triangle relative to theta over the hypotenuse. And it tells us that the tangent of theta is equal to the opposite side over the adjacent side. Looking back over here to our triangle we have highlighted, this angle is theta. Now, so what is sine of theta in this example? Well, we know our distance of our adjacent side is some x, and we know the height is some y. Therefore, our sine of theta is going to be equal to y over our hypotenuse, which is 1, which is just y. And our cosine of theta is going to be equal to what? Well, it's going to be equal to x over 1, which is just x. Therefore, you can think of the x value of the unit circle to be cosine theta. And you can think of the y value of our unit circle to be sine theta. Therefore, any coordinate on our unit circle can be thought to be cosine theta, comma sine theta. This cosine theta, sine theta is the coordinate point for any location on our unit circle. Now let's think about tangent. What is tangent? Tangent is, again, tangent theta is equal to opposite over adjacent. We just learned that the opposite side of theta is sine, and the adjacent side to theta is cosine. So tangent of theta is equal to the sine divided by the cosine. Now what should this remind us this should remind us of the slope of an equation, because sine was the y value, that was our rise, and cosine's our x value, that's our run. So sine over cosine gives us the slope of our point. Therefore, here let's draw a line. Whatever the slope of this line is at some given point on our unit circle is equivalent to the tangent of theta, of this point. Okay. So there's some connections between theta and the unit circle. Let's continue forward and find some specific examples. So let's draw out another circle. Okay, here we have a unit circle. So some of the most common points to find on the unit circle, and ones I recommend having memorized, are 30 degrees, 45 degrees, and 60 degrees. So let's focus in on those three. So here we have 30 degrees. This full distance would be 45 degrees, and this full distance would be 60 degrees. So again, these all represent coordinates on our unit circle, and the coordinate for these points are our cosine and our sine values respectively. So let's zoom in on firstly this 30-degree angle. If we complete and form a right triangle with this 30-degree angle, what do we have? Here, I'll change to white. So we have a right triangle. This angle here is 30 degrees. That means this angle here must be 60 degrees. Now this should remind you of our special 30, 60, 90 right triangle. And here I'll pull the triangle out so it can be a little bit easier to write and talk about. We have our 30, 60, 90 right triangle. And in our 30, 60, 90 right triangle, we know that the side opposite 30 degrees can be represented as s. The side opposite 60 degrees is represented as s square root 3. And the hypotenuse, the side opposite the 90, is 2s. We know that sine is opposite over hypotenuse. Therefore, sine of 30 degrees is going to be s over 2s, which simplifies to 1/2. And we know that cosine of 30 degrees is going to be what? Well, it's going to be the adjacent side, s over root 3. S root 3 over 2s. And the s's cancel out, leaving root 3 over 2. So the coordinate for this point here at theta being 30 degrees is going to be our cosine value of root 3 over 2 and our sine value of 1/2. Similarly, we can find the coordinates for cosine of this point here, cosine of 60 degrees and sine of 60 degrees. Here we still have our special right triangle, but instead we're looking from this vantage point. So sine is opposite over adjacent. So from our 60 degrees, sine will be s root 3. I said adjacent, I meant hypotenuse, over 2s. And hey, notice that sine of 60 is the same as our cosine of 30. It's going to be root 3 over 2. And our cosine of 60 degrees is s over 2s, which is 1/2. So it just flip-flopped with the 30-degree angle. Now let's find the coordinate for this point here, our 45-degree location. Here I'll go to this left-hand side. Let's draw a triangle. Here we have a 45, 45, 90 triangle. And this is another special right triangle where we know the legs of the triangle to be S and the hypotenuse to be S root 2. Thinking of SOHCAHTOA, we know that the sine of 45 degrees, the sine of our angle, is going to be equal to opposite, which is S, over the hypotenuse, which is S root 2. Now we cannot have a radical in our denominator, so to rationalize the fraction, we're going to multiply it by root 2 over 2. And so this simplifies to, and our s's cancel, of course, so this simplifies to root 2 over 2. So sine of 45 is root 2 over 2. And notice that cosine of 45, notice how cosine of 45 is also going to be side over side root 2. Therefore, it will also simplify to root 2 over 2. So sine and cosine of 45 degrees are both root 2 over 2. Excellent. So now this is how, using our special right triangles, we were able to find the sine and cosine value for 30 degrees, 45 degrees, and 60 degrees, respectively. Let's continue this thought. Now, so far, we've just been focusing in quadrant 1 of our unit circle. Here, let's get a new unit circle going. So far, again, we've just been focusing in on quadrant 1. If you're unfamiliar, the quadrants of our coordinate system go counterclockwise this way. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. Also notice how quadrant 1, both your x and your y value are positive. Oops. It's positive and positive. In quadrant 2, your x value is negative and your y value is positive. In quadrant 3, both your x and y coordinates will be negative. And in quadrant 4, your x is positive, but your y is negative. Okay, let's not forget what we just learned. We just found 30, 45, and 60 degrees. So what were these positions? Well, 30 degrees here. Let's scroll up. Don't want to make a mistake. It was root 3 over 2 and 1/2. 45 degrees was root 2 over 2 and root 2 over 2. And 60 degrees was 1/2 and root 3 over 2. Now notice these are all positive. So what would we do if we wanted to find this angle here, this position here? What would we do? How could we think about it? And then what if we're told that this angle here is 45 degrees? Well, whenever we draw a reference 30-60, a reference right triangle, we see that we have a 45, 45, 90 right triangle. This is the exact same as this 45, 45, 90 right triangle over here. It will give us the same values. Therefore, this coordinate point, sine and cosine are going to be root 2 over 2, except the cosine value is going to be negative because it's in the second quadrant. Therefore, this point would be negative root 2 over 2, comma, positive root 2 over 2. All right, and that's because it's in the second quadrant. And what is the degree measure of this position? what is the degree measure? It's not 45. 45 is just this reference angle. But to find it, well, the first quadrant is 90 degrees. And then this extra little bit here would also be 45 degrees, since the full second quadrant is 90 degrees. Therefore, this full angle is 90 plus 45, which is 135 degrees. So theta equaling 135 degrees means that the cosine is negative root 2 over 2, and the sine is root 2 over 2. Okay, let's do another example. Let's look down to quadrant 4. So I'll erase this. So if we go down to quadrant 4, let's draw something here. And let's be told that this angle is 60 degrees. What will the sine and cosine be? Well, if this is 60 degrees, we can draw our reference right triangle, and we can think of, well, hey, in our first quadrant, we already found sine and cosine of 60 degrees. It was 1/2 and root 3 over 2. So this will be the same thing, except our sine value is negative because we're in quadrant 4. So this quadrant will be positive 1/2 and negative root 3 over 2. And what is this full angle? Well, this full angle is going to be 90 degrees plus another 90 plus another 90. That's 270. And then plus this little bit is 30 degrees. So this full thing to here will be 300 degrees. So this is true when theta equals 300 degrees. Okay, now let's solve some practice problems. Let's go solve some practice problems. Here, what do we have? Let's draw our unit circle. And what are our questions? It says, what angle does coordinate negative 1/2 and positive root 3 over 2 represent? Okay, so first of all, we need to ask ourselves, what quadrant are we in? Well, our x value is negative and our y value is positive, so that means we're going to be over here. Oops, let me get my pencil tool. That means we'll be over here in quadrant 2. And again, remember that your x coordinate represents your cosine value. So what do we remember for cosine being 1/2? Well, we can go up. When was cosine 1/2? Cosine was 1/2 here at 60 degrees. Okay, so how can we use that to our advantage when solving this problem? If we know that cosine of 60 degrees is equal to 1/2, and we know that this coordinate point is at negative 1/2, well, that means if we make some right triangle, this angle theta must be 60 degrees, and so this point will be the negative 1/2 and the root 3 over 2 in question. But we want to know what angle does this coordinate represent. It's not going to be 60. It's going to be whatever this full angle is. Okay? So what is that? Well, our first quadrant forms a right angle. That's 90 degrees. If this reference angle we just made is 60 degrees, that means this other bit will be 30 degrees. And 90 plus 30 is 120. So the angle that this coordinate represents is 120 degrees. Okay. What about the coordinate negative root 2 over 2, comma negative root 2 over 2? Well, which which quadrant are we in this case? Well, both our x and y are negative, so we are going to be in quadrant 4. We're going to be in quadrant 4. Okay, so we're down here. The coordinate is negative root 2 over 2 and negative root 2 over 2. And we know that, hey, whatever this angle here must be 45 degrees. And so what is the full angle in question? Well, quadrant 4 is maybe a little bit simpler. We know a full circle is 360 degrees, and we're 45 degrees short. So we're going to subtract 45 degrees from 360, and we get 315. So therefore, cosine of 315 degrees is negative root 2 over 2, and sine of 315 degrees is also the negative root 2 over 2. So this is 315 degrees. Next, we'll do this question. What is cosine of 120 degrees? Well, hey, let's not forget the problem we just solved. Look at the first one we solved. It asked us, what angle does coordinate negative 1/2 and root 3 over 2 represent? And we found that to be 120 degrees. So the cosine of 120 degrees is going to be negative 1/2. And what about this one? What is sine of 315 degrees? Again, we just solved this. We found it down here. We know that the sine is the y coordinate of our unit circle. And so we know that this is going to be negative root 2 over 2. And then lastly, what is tangent of 210 degrees? Okay, so we need to find out where 210 degrees would be, first of all. So what quadrant would that be in? Not here. Let me try to clean this up a little bit. Let's clean this up a little bit so we can more clearly see everything that's happening. Okay, so where would 210 degrees be? Well, we know that this would be 90 degrees, this would be 180 degrees, and then 180 plus an additional 30 degrees takes us to 210. So here we're in the third quadrant, where this little bit here is 30 degrees. So we can form a right triangle, and we can think about what this coordinate would be. Okay, if we formed a right triangle with 30 degrees and we're in the third quadrant, we know that both our x and y values will be negative. We can scroll up and see what we found 30 degrees to be. And here we can see that we found 30 degrees to be root 3 over 2 for cosine and 1/2 for sine. So let's use that. We can go back down, and since we're in the third quadrant, both are negative. So we have root 3 over 2, comma 1/2. They are both negative. Yeah, they're both negative. Negative root 3 over 2 and 1/2. Okay, excellent. And then we want to find tangent. Well, how do we find tangent? Well, we know tangent is just sine over cosine. So we're going to take negative 1/2 and divide it by, oops. Oh no, that's right, my bad. We're going to take our sine value, which is negative 1/2, and divide it by our cosine value, which is negative root 3 over 2. Now dividing is the same thing as multiplying by the reciprocal. So negative 1/2 times 2 over root 3. Negative 2 over root 3 rather. So since both terms are negative, our answer is going to be positive. Notice how these 2's cancel out, and we are left with negative 1 over root 3. And we need to radicalize this fraction, so we can multiply both top and bottom by root 3, and this is positive. And we get root 3 over 3 for tangent of 210. So tangent of 210 is root 3 over 3. Again, we found that by finding this coordinate point and then dividing the sine and cosine value. Another way to do it is, of course, you can use SOHCAHTOA and just think of the opposite over the adjacent, and you can get root 3 over 3 that way as well. All right, excellent. Let's do a quick recap. I feel like we covered quite a bit for this video. In the next video, we'll talk about how to go from degrees to radians. So stay tuned for that. But as a quick recap, we learned what the unit circle is. It's simply a circle with a radius of 1. The equation for said circle is x squared plus y squared, and that equals 1. We know that any coordinate that falls on our unit circle can be given by the cosine of theta and the sine of theta as its coordinates. And that we also talked about how the tangent of theta is the slope of the line that touches said coordinate. After that, we solved for different coordinates, points on our unit circle, the 30 degrees, the 45 degrees, and the 60 degrees. We used our special right triangles to solve for said coordinates. And then we talked about how this extends to all 4 of our quadrants. Okay, the first quadrant's going to be positive and positive. The second quadrant, our x value's negative and our y's positive. In our third quadrant, both x and y are negative. And in our fourth, x is positive and y is negative. And then lastly, we solved some practice problems. Again, I hope this video was useful. Let me know down in the comments below, and I'll see you in the next video.